In the last few classes, we have looked at pattern matching, and let's look at it in some more detail. So, what are patterns? Okay, so it is recursively defined as follows. So, in the base case, we have variables like for example x is a pattern. Okay. Then the second case is a wildcard, which is written as underscore is a pattern. Okay. So the underscore. Okay. And for tuples, if P1 and P2 are patterns, and so is P1, P2. And similarly, for n tuples, 3 tuples, 4 tuples, etc. Okay, and for lists, the pattern is if P and PS are patterns, then P on PS is also. Okay. So this is what patterns are. Let me just mark it as code fragments. Okay. So what does pattern do? We can use patterns as ways to bind variables. Okay. So patterns' ultimate aim is to bind variables so that they can be used. Okay. So what does patterns do? So there is a notion of pattern matching. Okay. So we have to say when given an expression for value and a pattern value, let's say v, and a pattern pat, when does there are two things. Okay, first, does pat match value v? Okay, successfully. Okay, when does it fail? Okay. Second, what are the resulting variable bindings? Okay, these are the two questions that we need to answer. Okay, so now let's look at the rules of pattern matching. Okay. So we have a pattern. Okay, and pattern can be any one of this. Okay, can be a variable, say x. It can be P1, P2. Okay, it can be P1 double column or P, PS, where in this case P1 and P2, P, PS, they are all patterns themselves. Okay, so we need to know the type of the value v which it matches. Okay, so in the case of variable, it matches any type. Okay, and form of the type of v, well, any value is fine. Okay, and what bindings? X equal to v, that is the binding that is created. Okay, in the case of P1, P2, the type should be something like, it should be a Cartesian product. the value should look like v1, v2, and creates so it recursively creates a matching on match p1 with p1 and p2 with p2. Okay. In this case it should be a list. The value should be of the kind p1 column ps matches p with p and ps with ps. So remember, p1 and p2 are recursively patterns and their matching will happen at this point. A wildcard is just like the variable case. So it can be any type, any value, no bindings created here. Okay. These are the four cases that we have. Okay, so in this point, the type checking is done. This column 2 compiled. So if you try to match, let's say, a list pattern with a tuple, then you get an error at compile time. Okay, so that is the static. The form of value, that is column 3, is checked at runtime. And there's a good reason for this, because suppose you start with something like val. Firstly, the first thing, type checking is done at compile time is always the case. We are in static type checking world. But in the case of, suppose we have val v equal some x equal to some expression e, okay, or maybe let's look at this case. Alright, so unless you reduce this e, there is no way to know whether it is a value of, whether it is empty list, or is it the double colon vs. Okay. So generally this form is checked at compile time, at runtime. Okay, so I should say that this pattern matches a list, and form should be this, and no bindings created. Okay, just to complete this. Okay, so this is the rules of pattern matching.